Colin Reeder's response to this is typical of other geologists that have reviewed Schoch's claims in this regard. He says, quote, "Schoch has made the point that I have not commented on the geophysical data that he has obtained from within the Sphinx enclosure, nor have I considered the implications of this work on the dating of the Sphinx. My reason for not addressing the seismic investigations was primarily connected with the value of this form of investigation when used in isolation. Geophysics provides an immensely useful range of non-destructive tools. However, in all cases, these techniques can merely be considered as prospecting tools. It is common for one geophysical technique to show anomalies where no features exist, and vice versa. In addition, different results can often be obtained by the same technique. Even additional factors come into play. Conclusions drawn from geophysical investigations should always be confirmed by intrusive methods. No intrusive investigation has been undertaken by Schoch." An illustration of the vagaries of geophysical survey is provided by the team from Waseda University in Japan, who used two advanced geophysical techniques within the Sphinx enclosure, ground-penetrating radar and microgravity techniques in their first season. Yoshimura et al. Used GPR, ground-penetrating radar, with a frequency of 150 megahertz and identified two potential cavities in front of the Sphinx. During their second season, however, the same techniques were used, but with a reduced frequency of 80 megahertz. No significant anomalies were encountered at the appropriate locations. It is not possible to be certain which set of geophysical data is to be believed. However, as Yoshimura et al. Stated, it was found that the existence of a cavity could not be confirmed without a boring operation. In Schoch's opinion, however, the seismic geophysical surveys undertaken by Dr. Thomas Dobecki and himself confirm his pre-5000 BC date for the original construction of the Sphinx. Schoch's argument can be summarized as follows. After excavation of the Sphinx, the newly exposed rocks, particularly the floor of the enclosure, began to weather. In his recent criticisms, Schoch appears to advocate arid, subaerial weathering as the main agent of this degradation, dismissing the effect of modern rainfall, etc. However, in his earlier papers, particularly the first paper that he co-wrote with Dobecki, a wider range of weathering agents are considered, including subsurface dissolution and karstic development related to dissolution of the limestone. Schoch considered that if the Sphinx had been carved in one operation, the depth of the weathering below the floor of the Sphinx enclosure would be uniform. He argued that the shallower weathering at the rear of the Sphinx indicated that the excavation at this location had been cut more recently. Zahi Hawass had indicated that a number of masonry blocks on the rear end of the Sphinx date from the 4th dynasty. Schoch associated this restoration with excavation at the rear of the Sphinx, and on this basis argued that the more shallow weathering represented a late phase of excavation, which would have been limited to the rear of the Sphinx enclosure, which had been undertaken in the 4th dynasty. As the weathering elsewhere across the floor of the enclosure is between 50 to 100% deeper, Schoch argued that the enclosure had been excavated some 50 to 100% earlier than the 4th dynasty. This is about 7000 to 5000 BC. In this way, Schoch was able to, quote, confirm his earlier date for the Sphinx, which he had initially established on the basis of a known period of rainfall. It is necessary to question, however, the validity of Schoch's key assumption that the result of the seismic geophysics actually represent evidence for weathering rather than some other factor. Schoch's conclusion that the seismic survey indicates anomalous shallow weathering at the rear of the Sphinx is only one possible interpretation of the data, as discussed by Harrell. There are other equally valid interpretations, including one in particular that may cast some doubt on Schoch's interpretation. In his original KMT article, Schoch discusses 4 seismic lines within the Sphinx enclosure. The line at the rear of the Sphinx, line S3, suggested a depth of weathered limestone in the order of 1.2 m. 3 further lines, S1, S2, and S4, on the north and south of the Sphinx, parallel to the body and in front of the paws, indicated weathered rock to a 1.8 to 2.5 depth. However, the KMT article simplified the original seismic work, omitting any discussion of seismic line S9, which ran across the floor of the Sphinx temple. In their joint paper, Dobecki and Schoch reported that S9 indicated weathering to 1.2 to 1.5 m depth. In addition, they state that the depth of the weathering indicated by S4 in front of the Sphinx approached 4 m, not the 2.5 m stated by Schoch in the KMT article. If these depths are plotted on an east-west section through the Sphinx enclosure and the Sphinx temple, bearing in mind that the floor of the Sphinx temple is cut 3 meters lower than the floor of the Sphinx enclosure, the, quote, weathered depths can be connected with a subhorizontal line that closely parallels the dip of the strata. Schoch's weathered zone may therefore be a function of the structure of the member 1 rock, reflecting the bedding of the limestone beneath the Sphinx enclosure. So in other words, this weathered rock may just be the way of the rock is laying. It's laying on a slant. To make a long story short, if Schoch is right about this subsurface weathering, he will need to have cores drilled at the site to prove it, as it will be assumed to be sloping natural bedding otherwise. Regrettably, the Egyptians drilled below the floor in the 1990s to determine how high the water table had risen, but they did not preserve any samples of the subsurface rock. A sample may be possible to take if somebody remembers to do so next time there is drilling to monitor the water table. In conclusion, I think the following points are persuasive. The very selective weathering on the western side of the western enclosure wall, and not on the other sides of the enclosure nor on the Sphinx, are itself very positive signs for Reeder's theory being true, especially considering the positive evidence for the Sphinx enclosure being a natural drainage for the plateau. Number 2. The rainfall during Reeder's revised construction date, 400 years earlier than the mainstream view, but 2,500 to 5,000 years later than Schoch's, was more than enough to produce the erosion seen at the Sphinx site. The rainfall tapered off over thousands of years. It did not end abruptly. Number 3, the other aspects of this debate, such as the context and the other buildings around the area, are in Reeder's favor, which can be understood by reading some of the articles below. I have here a link section where you can read different articles about this, and then I have Reeder's responses to Schoch's criticisms. So I took from those articles a counterpoint discussion here. I'll start with what Robert Schoch first says about Colin Reeder's criticisms of him. He says, "In my opinion, the nature and degree of weathering and erosion degradation on the Sphinx and in the Sphinx enclosure is much different than what would be expected if the Sphinx had not been carved until 2800 BC or even 3000 BC. Also, mud brick mastabas on the Saqqara Plateau dated to circa 2800 BC show no evidence of significant rain weathering, indicating just how dry the climate had been for the last 5,000 years. I continue to believe that the erosional features on the Sphinx and in the Sphinx enclosure indicate a much earlier date than the 3000 or 2800 BC. It strains credulity to believe that the amount, type, and degree of precipitation-induced erosion seen in the Sphinx enclosure was produced in only a few centuries." Reeder responds, "A series of 1st and 2nd Dynasty mud brick tombs are situated on a limestone ridge at Saqqara, overlooking the Nile Valley. These early tombs, which conveniently are considered to predate the Sphinx, show little evidence of degradation by rainfall. Schoch has taken this in support of his pre-5000 BC date for the Sphinx, arguing that the rainfall which eroded the early Sphinx had ended by the time the later mud brick tombs were built. We know, however, that significant rainfall has been experienced in Egypt, and that in appropriate hydrological setting, the resultant runoff can lead to considerable destruction. Reisner showed that sometime after its 4th Dynasty construction, mud brick elements of Menkaura's Valley Temple were damaged by rainfall runoff. I also consider runoff to be a significant agent of degradation at the Sphinx. Unlike the Sphinx and Menkaura's Valley Temple, however, the mud brick tombs at Saqqara were built on an area of high ground and do not lie within any natural catchment. These tombs will not, therefore, have been exposed to any significant runoff. That the 1st and 2nd Dynasty mud brick tombs at Saqqara do not show any evidence for erosion is, therefore, a function of their hydrological setting rather than their age. Although it is beyond question that these tombs will have been exposed to rainfall, the fact that they are not significantly degraded, as Schoch has pointed out, demonstrates that rainfall itself has not been a significant agent of degradation in Egypt. We move on to the final criticism of Schoch about Reeder's theory. He says, "I do not find the dating of the Sphinx on the basis of the, quote, known use of the stone in ancient Egyptian architecture, end quote, convincing. I would point out that massive stonework erections were being carried out millennia earlier than circa 2800 BC. In other words, parts of the Mediterranean, for instance at Jericho in Palestine, even in Egypt. It is now acknowledged that megalithic structures were being erected at Nabta, west of Abu Simbel in Upper Egypt, discussed in the text of my book, Voices, by the 5th millennium BC, and that pre-dynastic Libyan Palette, circa 3100 to 3000 BC, now housed in the Cairo Museum, records fortified cities, which may well have included architectural stonework along the western edge of the Nile Delta, and at a very early date. I find it quite conceivable that architectural stonework was being pursued at Giza prior to 2800 or 3000 BC. Reader responds to this, saying, having advocated a pre-5000 BC date for the excavation of the Sphinx, Schoch has attempted to establish a role or context for his early Sphinx. In search of such context, Schoch has suggested links with Jericho, from where stonemasonry is known, circa 8000 BC, and stone artifacts from the Nabta Playa in southern Egypt from about 6000 BC. I have investigated these suggested links and have found them both unconvincing. With respect to the possibility of links with Jericho, Michael Bagent, in his book Ancient Traces, links pre-dynastic pots found in Giza, see also my papers, to evidence of traders from Jericho, the Jericho region, who had settled in the late pre-dynastic town of Mahdi across the Nile Valley from Giza. Bagent describes how many of the pottery remains encountered during the archaeological excavation at Mahdi were clearly influenced by Jericho. He concluded that people from Jericho had settled in Mahdi, bringing with them their knowledge of working masonry, and he implies building the Sphinx. Whilst this link is intriguing, it cannot be substantiated by archaeological evidence from the site. An important publication on the subject is Mahdi I, the Pottery of the Pre-Dynastic Settlement, in which the authors discuss the presence of Palestinian, including Jericho, pots from the Chalcolithic age, 4000 to 3000 BC. Not only is this date not consistent with the 5000 BC date advocated by Schoch for the construction of the Sphinx, the authors note that the Palestinian pots were of a single type and represented only some, that is 3% of the total assemblage. Given the rich variety of forms of Palestinian ware, the firm conclusion reached was that these pots were not imported in their own right, nor were they brought with settlers. Their presence in Egypt was simply due to the fact that they were the standard container for a certain class of goods imported from Palestine. As for the Nabta Playa, well, the Sphinx and the Sphinx Temple actually have very little in common with the stone circle discovered at this site in southern Egypt, dated to approximately 6000 BC. The scale of the two monuments could not be different. The Sphinx is some 74 meters long, whereas the Nabta Circle is only 4 meters in diameter. Unlike the Sphinx Temple particularly, which consists of careful, quarried, worked and placed masonry, the Nabta Circle is built from roughly hewn blocks. A number of large worked stones have also been found buried in the sand at Nabta. While these monoliths show some advanced features of working in stone, they do not represent masonry and cannot therefore be associated with the Sphinx. These distant sites, Jericho and Nabta, failed to provide the early context for the Sphinx that Schoch has sought. More to the point, however, is that we do have archaeological evidence from Egypt for the period of 5000 BC. The capabilities of the culture from this time are well established, however they do not include the working of stonemasonry. And that concludes this episode of Ancient Aliens Debunked podcast. My name is Chris White. This blog post was called The Age of the Sphinx, Colin Reeder versus Robert Schoch, and it has a lot of references on the blog post itself, so if you want to see that, join us at the website ancientaliensdebunked.com. Bye-bye. Colin Reeder's response to this is typical of other geologists that have reviewed Schoch's claims in this regard. He says, quote, Schoch has made the point that I have not commented on the geophysical data that he has obtained from within the Sphinx enclosure, nor have I considered the implications of this work on the dating of the Sphinx. My reason for not addressing the seismic investigations was primarily connected with the value of this form of investigation when used in isolation. Geophysics provides an immensely useful range of non-destructive tools. However, in all cases, these techniques can merely be considered as prospecting tools. It is common for one geophysical technique to show. An illustration of the vagaries of geophysical survey is provided by the team from Waseda University in Japan, who used two advanced geophysical techniques within the Sphinx enclosure, ground-penetrating radar and microgravity techniques in their first season. Yoshimura et al. Used GPR, ground-penetrating radar, with a frequency of 150 megahertz and identified two potential cavities in front of the Sphinx. During their second season, however, the same techniques were used, but with a reduced frequency of 80 megahertz. No significant anomalies were encountered at the appropriate locations. it is not possible to be certain which set of geophysical data is to be believed. However, show anomalies where no features exist, and vice versa. In addition, different results can often be obtained by the same technique. Even additional factors come into play. Conclusions drawn from geophysical investigations should always be confirmed by intrusive methods. No intrusive investigation has been undertaken by Schoch.